we're going to process the data that you accumulated while doing Kinetics 1, determination of a rate law. So we're going to try to figure out that rate law, and here it is again. And in order to figure out the rate law, we first have to figure out the concentrations of the ions that we're using. And then we'll talk about the rest of it. So when we're talking about the concentration of iodide, Ki breaks down immediately in aqueous solution to K plus and I minus because it is a strong electrolyte. So the concentration of Ki is equal to the concentration of iodine. All right? So let's find the concentration of iodine in this mixture. To begin with, we know the molarity initially. It's right here. And we know the initial volume we use. It's right here. We will know the total volume. It's all of this that we mix together. And we're looking for M2. So M2 is what we're looking for. M2 equals M1 V1 over V2. So let's quickly look at one of these, and then we'll go on and look at what's happening with persulfate. So the molarity of iodine is equal to, let's see, the first molarity, the molarity of the initial solution, is 0.2 molar. So 0.20 molar times our initial volume. And I'm going to leave everything in milliliters so it'll cancel out. So 2.0 milliliters. And, oh, I'm leaving off sig fig, sorry about that. And the total volume is 2, 4, 6, 8, 10, 11.00 milliliters. Now, as we look at this, we can cancel out our milliliters, and we're left with 0.2 times 2.00 divided by 11.00, or our first, for run 1, our first concentration of iodide is going to be equal to 0.0364. So we're going to take that and we're going to put it in our data table, which is a long ways away. Here it is. And you can see I've started to fill in the data table. So 0.0364 for iodide. Now you'll notice it says the same thing for persulfate. So let's go back and look. Now if we look at persulfate, once again, when you put ammonium persulfate into water, that persulfate separates out as a polyatomic ion. So our concentration of NH4 S2O8, ammonium persulfate, is 1:1. Okay, so it equals, it's the same as the concentration of persulfate. Okay, so we can go ahead and find our concentration of persulfate again. So again, we're going to be using M1V1 equals M2V2. So this is our M2, and it's M1V1 over V2. So let's start plugging in. M1 is 0.200 molar times, we're using 2.00 milliliters, divided by 2, 4, 6, 8, 10, 11, I guess that hasn't changed, 11.00 milliliters. Our milliliters cancel, and lo and behold, this comes out to be the same thing as our last concentration, the concentration of iodide, equals 0.0364 molar. So again, that goes into data table 2. And there it is. Now, as we look at the concentrations and the numbers of V1 that we've got, we'll see that experiment 1, all 3 trials of it are going to have the exact same concentration of iodine and the exact same concentration of persulfate. With experiment 2, you're going to double the concentration of iodide, but the concentration of persulfate will stay the same for all 3 runs. Okay, so obviously those are the runs that we're going to be checking out and studying iodide with. Last, the 3rd experiment is going to return to our initial concentration for iodide and double the concentration for persulfate. Okay, now we can use all of these and our rates to determine the order of the reaction with respect to iodide and persulfate. So now you can see I filled in the table here. Let's go figure out where we get this from, okay? So this is the rate of appearance of iodine. Okay, so looking back up here, you can see that the rate of appearance of iodine is the same as the rate of disappearance of persulfate, and also directly related to the rate of disappearance of iodide. So we can use this to find our rate of reaction. Now remember, this is rate of appearance we're looking at, but we have to figure out how we got that rate of appearance, that delta I2 over change in time. This is how we find the concentration change for iodine. First, we're going to find the change in molarity, or in moles of iodine. Okay, so we're just going to look at the top part first. And if we look back at that first data table, we have 2.00 milliliters of thiosulfate, which means that 0.00200 liters of thiosulfate. Okay? Now, also if we look there, we can see our concentration for thiosulfate is 0.012 molar, or moles per liter of thiosulfate. So now we can cancel out our liters of thiosulfate. Don't put anything in this bottom. This is molarity, moles per liter. We just broke it down so we could see how we end up with moles of iodide. So now, lastly, we're going to use our molar ratio. So 1 mole, again, look up at that initial reaction, 1 mole of iodine per 2 moles of thiosulfate. Now our moles of thiosulfate cancel, and we are going to end up with moles of iodine. Okay, well that's fine, but it doesn't really tell us the molarity, and that's what we need to have. We need to have, and this is step 2, the change in the concentration of iodine. Remember, we're using thiosulfate here because that is going to be consistent throughout all of the runs, and that will allow us to determine just exactly how many moles of iodine have been reacted before we can see it. All right, so here we go. Iodine. Now we're going to take our moles of iodine and divide it by the total volume, which we've already figured out. That was 0.01100 liters. So now we end up finally in our moles per liter, which is going to be our delta I2. Okay? Right there. Now, in order to find, that's the change in iodine concentration that this particular experiment has to go through before we can detect the iodine. Now we have to find the rate based on the appearance of iodine. And in order to find the rate based on the appearance of iodine, we have to divide it by the time it took. So time elapsed before detection of iodine. Okay, so we're going to take this molarity and divide it by the time which you measure. Okay, you measured this. All right, so let's go back to that data table and see what we've got. When we look at the data table, you can see that I have figured out here the change in the concentration of iodine from the start to when we can actually see it. And when we do this over and over and over again, our amount of thiocyanate, which is what the iodine is depending on, does not change. So once you have figured out delta I2 for one reaction, it's done for all 9 of them. Now, this is the data part, not calculations anymore. Everything's been calculations up to this point. This is the data. These are the times you took. And you can see that I have 3 times that I've taken in the past using past experiments. Now, remember, rate is equal to the change in the concentration of iodine, which is right here, divided by the change in time, which is right here. So when we divide these two, that's the rate I got. Okay? So now what are we going to do with this? We have our rates, we have our concentrations. So now we have a table that we can actually use to determine our M and N, the exponents for iodide and the exponent for persulfate. So we're going to go back. This is going to happen 3 times, okay? Because you have 3 runs for each experiment, okay? So each experiment has 3 trials or 3 runs. So you're going to be doing this calculation 3 times. So your rate from, this is experiment 2, divided by your rate from experiment 1. Plug in experiment 2's concentrations and rate. And then we're going to compare it to, or divide it by, experiments 1's rate and concentrations. Now, because in experiment 1 we held the persulfate concentration constant, this drops out. And our rate constant also drops out. So we end up with, from this, rate 2 over rate 1 equals concentration of iodide in experiment 2 divided by concentration of iodide in experiment 1 to the M. All right, so that's what you get out of this. But that makes M very difficult to figure out. So we took the log of both sides. The log of rate 2 over rate 1 equals M. That's why we take the log. M turns out to be a coefficient here. M times the log of the iodide concentration in experiment 2 divided by the iodine concentration in experiment 1. Now, this is going to be the same thing for all 3 trials. Remember, I said we did this 3 times? So all 3 trials, it's going to be the same. The rate 2 and rate 1 will change and a little bit, and we'll be able to find M. Here I've written out rate 2A. That's the very first run you do, and iodine 2. Then rate 1A and iodine 1. All right, so now we should be able to have figured out the M's. All right, log rate 2 over rate 1 equals M at times this. And these are calculated, so we'll be able to figure out M. Once you find the M's for all 3, go ahead and average them. We're going to do the same thing when we calculate N, only now when we calculate N, we're going to be using experiment 3 and experiment 1. Now in experiment 3 and experiment 1, we're holding our iodine constant as well as our rate constant. So this is going to be rate 3 divided by rate 1 equals persulfate 3 divided by persulfate 1 to the N. Again, taking the log, we can get this nicely separated out into log of rate 3 over rate 1 equals N, and that's what we're looking for, times the log of these calculated concentrations. So these will be the same for trials A, B, and C. All right, so you should be able to find the N for trials 1 and 3. And that you'll again average, and that's going to allow you to figure out the rate law. You will know rate equals K, concentration of iodide, and that you will have learned, that you will have discerned, and persulfate, and again, this you will just have found right up here. And this will have been in the first one. So now you'll have a pretty good idea of what your rate law is. Now, once you've found it out, we're going to have you round M and N to the nearest whole number. Okay, so if you came up with 0.75 here, you would round it to 1. And if you came up with 1.12 here, you would again round it to 1. Now, using this partially completed rate law, we can actually find the K. We can solve for the K using these rounded numbers, and that's just rate divided by iodide to whatever it is, times persulfate, whatever it is. And that'll give you K. And you'll find K for the 3 experiments. Now your M data will go in here, your N data will go in here, and you'll find your rate constant for all 9 trials. Now, I want you to be absolutely sure you're looking at these things correctly. Back here with rate, you'll notice that this column already is in times 10 to the minus 6th. And this column is times 10 to the minus 3rd when you enter those. Okay? This last thing, you're just going to be finding the averages with the 3 sig figs and then round it And then finally, you're going to write the whole rate law, including M and N and K. And that'll be it.